I see we have some empty seats today. I can move that up. There we go. So today, like I said, the big moment of our lesson, big point of the lesson, is figure out what is a function. Is it a function? Now, there's different ways to do it. You can do it algebraically. Tomorrow we're going to talk more about how to do it graphically. Maybe you remember from 8th grade math, the vertical line test. It's a real exciting topic. We're going to talk about that tomorrow too. Of course, how to evaluate them. Super easy. We're plugging some numbers in for x and doing some calculations. We're going to talk about domain. Domain is very important, what you can put into the function, because there are some restrictions sometimes, and just different ways you can represent them. That's all it is today, kind of an introductory section. So, lots of vocab, different things to look at here. So, definition of a function. A rule that where each element of the domain has exactly one element in the range. So that is our formal definition of a function. But I feel like we almost have to talk about the other words in that definition, the vocabulary, to really know what the heck a function is. For instance, domain. Domain is all of your input values, what you are putting into the function. Now when we start talking graphically a little bit more, that is also your x-coordinates. So when I'm talking on the graphs tomorrow, I'm thinking x-axis, how far left, how far right does the graph cover. Range, of course, is the opposite, all of the output. And your y-coordinates. So if I'm looking at the graph and I want the range, I'm thinking how far up, how far down does it cover. Now, specifically today, definition of a function, this is the key. Each element of the domain, so each x-coordinate, every time you put a number in for x, you can only have exactly one answer come out for y. So, pro tip, if we have some plus or minus happening on some problems, and you have two answers technically, that's going to be a problem for us, okay? Notation. This little mathematical symbol, you probably have seen this before. That, of course, is f of x. That's how you say all that. All right. So, different ways you can represent functions, of course. You can do it with equations. You can do it with the graphs. We're going to talk about this mapping over here. You can think of it as a machine where you put a number in for x, do some calculations, a little magic happens, and then it spits out the answer, f of x. So, of course, function is huge for us. There are a lot in life in the real world, like your height is a function of your age. That's true. I'm probably shrinking as I get older. Temperature is a function of date. Cost of mailing something is a function of how heavy it is. It's dependent on that. So a lot of functions in life. That's why we dedicate an entire chapter to talking about functions. All right. So first up, here we go. A function is defined for the formula f of x equals x squared plus 4. Express in words how f acts on the input to produce the output. So you're really just kind of looking at the equation and explaining the calculations. So I'm looking at this equation and I'm like, okay, all right, cool. I want you to square the input and then add 4 to it. And that's literally what I'm going to write down. Okay, they want me to square x and then add 4. So they just want to make sure that you understand what your operations are. Okay, evaluate the different functions. So we're going to put 3 different numbers in for x. First, we're going to do 3. Now, most of this you can do mental math on and just write the answer down. That's really fine. I'm going to write out all the work, of course. So we're going to do 3 squared plus 4. So 3 squared, 9. 9 plus 4. Got it. So what I'm after from you is that you get the 13. Do I need to see on your homework that you write down 3 squared plus 4? No. But for your notes, I'm writing it down there. Okay, let's do f of negative 2. So same process, negative 2 squared plus 4. Negative 2 squared, 4. 4 plus 4. And then we're going to put in, we're getting really fancy now, square root of 5. So square root of 5 squared plus 4. Now, even though that looks a little crazy, it's still pretty easy, because what squaring and square root do? Cancel. So you have 5 plus 4, 9. So just different ways to evaluate your functions. And just when we start thinking about graphing, because there's a lot of graphing in this chapter, this also, you're really generating ordered pairs. If you put 3 in for x, you get 13. If you put -2 in for x, we got 8. Now if I'm graphing, let's get real, I'm not going to graph square root of 5, but you would get 9. So you're really just generating ordered pairs. It's just a different notation or style or way to look at it. That's all it is. All right, find the domain and range of f. Let's talk about, of course, let's start with domain. So domain, that's a big one. That comes up a lot. Domain is really asking what can you put in for x? What numbers can we put in? Or really, I kind of think of it backwards. Are there any numbers I can't put in? Are there any numbers that won't work in this equation? Is there anything I can't square? I'm like, I can square anything. I can square a negative. I can do it. I can square 0. I can square a square root. I can square a decimal. I can square a positive. I can square anything my little old heart desires. So I can use anything for the domain. So I'm just going to say all real numbers. I'm going to use the symbol for all real numbers. You could get, my trig kids like to do this. All real numbers. If you want to abbreviate it with that, I don't care. We can really live on the edge and go interval notation. Now, the range, let's talk about what we're going to get out of the function. So I'm looking at my function, x squared plus 4, and I'm thinking, okay, what am I going to get out of this function? So I'm thinking really in terms of what's the smallest answer I would get to the biggest answer. So first I'm thinking small. Well, you put a negative number in here. What's -1 squared plus 4? It's going to be 5. Okay, all right. Then I'm like, wait, what if I put 0 in? What's 0 squared? Plus 4. So I think 4 is going to be my smallest number. Or if you put 1 in, 1 squared plus 4 is 5. So the smallest number we're going to get is 4, and it's going to keep going larger than 4. So I'm just going to write it interval style. We're going to be 4 to infinity. Now sometimes I think that's a little hard maybe to mentally look at that when we first start that. So I'm a picture person. I always like to think about what the graph looks like just to show you. If you're going to look at x squared plus 4, and I'm thinking range, y-axis, I'm like, oh yeah, let me steal my picture here so I can write on it. I'm like, oh, there's my smallest number at 4, and I'm above it. So that's my range, 4 to infinity. So that's an easy way also to double check if you're more of a picture person. Let's delete that off. Okay. And we're going to get more into domain and range as we go. We're just kind of doing a little introduction to it here today. Oh, good. We get to draw. I love my artistic skills here. Draw a machine diagram for this. Okay, all right. So what they want you to do is I'm going to attempt to draw something like this, okay? And all I'm going to do is on the inside, I should just cut and paste this picture so I don't have to redraw it by hand. All I'm going to do is on the inside is write my function in there. I'm going to say that we're going to square x and add 4. Okay, let's draw it. This is going to be swelzer. So I'm going to do x as my input, and I'm putting that into the function, which it looks like a piece of candy. I can't draw that. I'm just going to put a rectangle. And I'm just going to say that we're going to square and add 4. That's what we're doing. And that kicks out, of course, your answer or your output. There is my lovely diagram. Nobody needs to look at that any longer. Whew. And I don't ever judge anybody's artistic skills. Oh, right. So let's do a little more with the evaluating. Let's talk about that just a little bit more. And then we're going to do some more evaluating when you have some variables. Just, that's where some FOILing and stuff comes into play. So let f of x be 3x squared plus x minus 5. Evaluate each of the function. And again, most of you can just do this in your heads, mental math. I'm going to write it out. So if I'm going to do f of -2, I have to do 3 times -2 squared. Now, watch your order of operations there. Plus -2 minus 5. Just makes it sound a little better. So order of operations, super conscientious. Exponent first, -2 squared, 4 times 3, 12. And then I'm just going to total this up. So I'm going to have 10 minus 5, 5. And I mean, can you use your calculators for these? Yes, but we should be able to do them in our heads a little bit. At least I hope. Hey, 0 is going to be pretty easy. I don't even know if I'm going to write a whole lot for that. Because if I put 0 in for both of these x's, it's going to eliminate those terms. 3 times 0 squared is 0 plus 0, so we just end up with -5. The last term. I like that one. I don't have to do a lot of work, right? Okay, 4. All right, I'm going to have to calculate 4. We have to do 3 times 4 squared plus 4 minus 5. That one you might want your calculator on. I don't know, maybe. 4 squared, 16. 16 times 3 is 48. That's not so bad. 48 plus 4, 52. 52 minus 5, 57. Got it. And again, I don't need to see all the work for your calculations. You can just do it in your head or in your calculator, I guess, if you had to. Are we doing the half in our calculator? Weak kids. We should be able to do it by hand. What if this was on a no calculator test or something? We don't need a calculator. We're good at fractions, right? Let's square 1/2. What's 1/2 times 1/2? 1/4. What's 3 times the 4th? Okay. So all I'm going to do now is make common denominators for everything, which think of that over 1. Let's make our denominators 4. So the first fraction I'm just going to leave. To turn this 2 into fourths, I'd have to double it. So I'm going to double the top. 2/4, 1/2, same thing. To turn this into fourths, I'd have to multiply by 4, so I'm going to do the top by 4. So 20/4 is the same as 5. Now just combine it. 3 plus 2, 5. 5 minus 20. Got it. Does it reduce? I'm just going to leave it. So just had to throw you a fraction because, you know, why not? Why not? Any questions on that? All right, there is a word problem here in the next one. I know I said not a lot of word problem, but this is a pretty easy word problem. You're still doing more of the same evaluating functions, but it's a word problem style. So, cell phone plan costs $39 a month. The plan includes 2 gigabytes of free data and charges $15 per gigabyte for any additional data used. The monthly charges are a function of the number of gigabytes given by that little crazy looking formula, which we're going to talk about that in a second, and then they want you to evaluate those. Okay, so I'm looking at this formula, which I'm going to steal over here so I can write on it. So this is really what we call a piecewise function defined by 2 or more expressions. That's all it is. So basically what this is saying is you're looking at these little back notes they have for you. So it's going to be 39. Your answer is just 39. If x is between 0 and 2, notice the equal to, so including 0. Any x's between 0 and 2, it just spits out 39 for answer. Any x over 2, you're going to have to plug in and calculate. So the trick is, like, ooh, am I using the top one or the bottom one? Depending on these values. So I'm looking at the 0.5 to start with. Okay. All right. So I'm asking myself, is 0.5 between 0 and 2, or is it over 2? Well, we all know 0.5 is between 0 and 2, so it's the top one. So it's just 39. I don't have to do anything else. I just write down 39. I like that one. Now we're going to do C of 2. More of the same. C of 2. So again, I'm looking at what I circled in red to figure out where am I plugging the 2. Is it just going to be the 39 or do I have to do some work? Well, you've got the equal to on 2 in the top one, so it's the top answer. It's just the 39 again. Okay. Seems hardly worth doing. Okay, let's do C of 4. I'm going to do a little work on this one because clearly 4 is over 2, so I'm going to have to plug the 4 in here and actually do some calculations now. So we're going to have to figure out what's 39 plus 15 times 4 minus 2. We can mental math it. I hear calculator keys, but we can mental math it. 2 times 15 is what? 30 plus 39. Okay. We don't need a calculator. Got it. So you'll start seeing, again, this is just kind of the introductory section. You're going to start seeing more functions like this. This is, again, what we call a piecewise function. It's defined in 2 different pieces, basically. We're gonna look at the graphs of them tomorrow too, but just kind of, showing you what it is to start it off with. Okay, net change, this is easy, more evaluating functions, I'm just gonna explain it to you. So the values of a function can change from one input to another, obviously. The net change as the input changes is given by that. So let f of x equal this, find the net change between the given values. Okay, this is super wordy for something that's very, very simple, okay? So from 1 to 3. So first you're gonna figure out f of 1, then you're gonna do f of 3. So let's just calculate that to start with. 1 squared, remember your function, x squared, 1 squared, 3 squared. And then basically, very simple, when we talk about change, eventually we're going to start talking about average rate of change, aka slope. It's all going to tie together. I just want to know what's the difference between them. So what's the difference from 9 to 1? 8. Your net change is 8. Your range from your answers is 8. So you're just going to evaluate the functions and then subtract them like you subtract in slope, rate of change, that's coming up in another section, and then it all ties together. Okay, same deal. We're going to do f of negative 2, figure that out, f of 2, and then we're just going to subtract them to get the difference between our answers. So negative 2 squared, got it, 2 squared, got it. So what's going to be your net change? 0, nothing wrong with 0, doesn't change at all, it flatlines. Because just like I said, this is going to tie into average rate of change, which is slope of a line. You can have a 0 slope, it just flatlines. So don't let 0 scare you. Sometimes 0 scares people when they get those for answers. All right, more evaluating functions, okay, all right. Just the only thing that's different, and probably you haven't seen Algebra 1 doesn't get into anything quite this crazy, you have more variables, okay? Same process, you're plugging this stuff in, but it's a little more algebra, a little more simplifying. So same thing. We're used to numbers. We're used to f of 2. You'd replace the x's with 2. Well, I'm going to put a in for all of those. So all I'm going to have is 2a squared plus 3a minus 1. And I can't combine the like terms. There are none. I can't do anything else with it. It is what it is. It's kind of ugly, but it is what it is. Okay. Now, this is going to be a fun one because it's going to take me some work. I have to do f of a plus h. So you are replacing all the x's now with an a plus h. Okay. So I'm going to have 2a plus h squared. That's going to be fun. 3a plus h. That's not so bad. Minus 1. Now we have the fun-filled job, feel my sarcasm, of simplifying this. Well, exponent first, order of operations. So I'm going to write this down twice. Oh, baby. And we're going to have to FOIL on it. This is the worst thing you got to do today. It's just a lot, it's time consuming. It's just a lot of algebra. So, choices. You could run 2 through here and then FOIL them together. I don't know, I tend to do the number at the end. It's just how I roll. I'm going to FOIL these together first. So I'm going to have a and a. Now remember, it's a perfect square. The middle terms are going to be the same. I'm going to combine them because I'm going to have one AH, another AH. I don't care that HA, AH, it's the same thing. One AH plus another, I'm going to combo it to 2. And then h squared. I'm going to take 3 through, plus 3a, plus 3h, minus 1. Okay, all right, still going. So now I'm going to distribute 2 and see if there's any like terms. 2a squared, 4ah, holy cow, 2h squared, 3a, that's a very sloppy looking a, I was going to write it, that's very set. 3a, 3h. Okay, take a minute to look at that and, have a slow tear come down your cheek maybe. Are there any like terms there to put together? Super fun. Okay, that's our answer. That was fun. Okay. Good stuff, good stuff. Now, you're like, oh my gosh, what are we doing? Look at C. You have a lot of the info for C already at your disposal, my friends. Because, look at, didn't we just, all that stuff I wrote in green, didn't I just do F of A plus H? I'm just gonna, I maybe should have put this on a new slide. I don't even fit it on here. I'm gonna put all the stuff I wrote in green for that. Didn't we do F of A? So I really have the green minus the red. It's going to be big all over H. Okay, I'm going to try to fit it in here. I think I can do it. I'm going to write small, maybe. So I'm going to write my green answer here. I'm trying to write it small. Okay, I'm going to put the fraction bar in. Now, careful here. I'm on this part. And my arm's starting to hurt. Oh, yours is too. Minus F of A. Minus. I have to subtract my red terms. So really, what am I doing to all their signs? Switching it. So I'm going to do minus 2A squared, minus 3A. Oh, gosh. And then plus 1. Ew. I barely made it. Okay. And we're over H. Okay. Now I'm taking a look. I'm like, okay, maybe some stuff cancels now, right? There's a lot of stuff and a lot of terms on the top. I see our 2A squareds are going to cancel. That's really good because I'm really running out of room here. I see our 3A's are going to cancel. And I see the 1's are going to cancel. Oh, good. Okay, I'm so happy. So I'm down to 4AH, 2H squared, 3H, over H. Can you simplify anything else? What do they all have on them? H. Chop an H out of everything. So if I take the H out, I'm going to take an H out of here, so you're down to a single H. Take the H out of here, you just have 3. And if I take H out of the bottom, I'm over 1. I'm not writing over 1. Whew! Now, you're probably like, why is she torturing us with this? This is awful. It's a little awful, okay? I won't fake it for you. This is what we call the difference quotient, This is a very hot topic when you get into calculus and you start solving limits and different things. There's a lot of difference quotient that pops up in it. So is there a million of these on the homework? No. But of course we like to introduce that to you. Okay? All right, just so now we're on to something a little less taxing, I hope. So we're going to kind of focus a little bit more on finding domain, okay? Because again, domain, what you can put into the function is critical. It keeps coming up over and over and over and over. We're going to talk about domains from a graph. We're going to get into all of it. So we already talked about domain at the beginning. We said it's what you're putting into the function. It's all of the x values. We already wrote all that down. But we always have to be a little careful when you have fractions and radicals. Specifically fractions, because what number can you not divide by? 0. So I'm like, oh, okay, that's going to be a problem. Square roots. You can't square root what type of number? Negatives. So I do have some restrictions. I can't just use any number my little heart desires. I have to be conscientious of those two things. So first thing I'm like, okay, all right, I got a fraction. I know I can't divide by 0. Okay, all right, I'm on. I also notice the bottom. I think it's easier if you factor if you can. I can factor an x out. That's what I'm going to do. Okay. So I'm thinking about specifically not what numbers I can use, but what numbers I cannot use. Okay? So if I put 0 in for this guy, I'm going to have 0 times who cares? I'd have 1 over 0. That is a problem. I can't use 0. What number can I maybe not throw in here? 1. Yeah, I heard it. 1 minus 1, 0. 0 times whatevs, who cares? 0. You're going to have 1 over 0, undefined. So I'm going to say for my domain, I'll remember this, and draw the symbol, but we can't use 0 or 1. So I'm just going to put a can't equal symbol So now we're a little more focused on our restrictions. Fractions are problematic. You cannot have a 0 in the denominator. So I reversed my train of thought. What can I use? Okay, opposite. And that's my restrictions. Now, square roots. I'm like, oh. Again, we can't just square root the 9 and x squared because of subtraction. You can only do that on product and quotient. Now, we said earlier, we can only square root positive numbers. We cannot square root a negative. I'm going to get a little more specific on that question. Can you square root 0? Yeah, we can square root 0, right? So I'm going to say my lovely expression under the radical, it's called the radicand, that's its fancy name if you wanted to know. I need 9 minus x squared to either be more than 0 or it could equal it. Because that ensures me it will turn out to be 0 or above. And then I can square root it. Now I'm like, oh man, I got to solve this. Hey, it's a throwback to the last chapter. We've got a quadratic inequality. I'm going to factor it. I'm going to get my answers. I'm going to test it on the number line. I'm going to do all that fun-filled stuff we did. Some of you can probably just look at it and get the answers right now. I am going to factor it. It's perfect squares, 3 plus x, 3 minus x. So of course my critical points, fancy name, that I'm going to put on my number line would be negative 3 and 3. So let's draw our number line. I'm going to put negative 3 on first. Now we've got the equal to, so I'm going to go close circle. And then just like last chapter, I'm just going to start testing. I'm going to pick like negative 4 on the left side. And remember, this is my inequality here, this first line I wrote in green that I'm working on. So careful, we got a lot of sign here, errors that could happen. First I'm going to put negative 4 in and square it. What's negative 4 squared? 16. So you have 9 minus 16. Is that going to be over 0? Good. Okay, I'm going to pick something in the middle. Keep it easy. 0. 0 squared, 0. 9 minus 0, 9. Yeah, that's looking good. So I'm pretty confident it's an and graph. And I'm going to pick like 4, 16, same thing. Doesn't work. Okay, so we can use anything for our domain from negative 3 to 3. I'm just going to write it in interval notation style, make it easy on myself. And if you're like, man, is that okay? Can I use that? Is that really working for us? Yeah, if you put negative 3 in here and square it, you have 9. 9 minus 9, 0. I can square root 0, sure can. If I pick a number in between, like 2. 2 squared, 4. 9 minus 4, 5. I can square root that. It'll be a decimal, but who cares? If I pick like 4, if I pick something bigger, 4 squared, 16, now I have negative 7. I can't square root that. So this will ensure that everything turns out positive underneath. All right, oh boy, we got a lot of problems on this one. A lot of problems. One, you have a square root. Can't square root a negative. Let me just that. And so I'm going to start with the negative part. Just like the last one, we'll be like, okay, I need this to be greater than or equal to 0. But I'm going to make a little change of Ruski on it here before I finish solving that. Can it actually equal 0 this time? You can't have 0 because you have a fraction. And it's in the bottom of the fraction, and we can't divide by 0. So I'm just going to fancy this up and say we have to strictly be over 0. Because if this equals 0, then I'm going to have 0 under the line, undefined. It's going to be a problem. Okay, I'm going to solve that. Notice it's not quadratic. It's nice and easy. I'm just going to subtract 1. Got it. Okay, so I'm going to say, just to make it look nice, all real numbers, t is greater than negative 1. Got it. Okay. And again, I mean, test it. If you put like 0 in, it's bigger. 0 plus 1, 1, square root of 1. Yeah, I got it. Okay. If I put 5 in, 5 plus 1, 6. Square root of 6. Yeah, it's going to work out for me. Okay. But this one, double trouble. You had the square root, and it was in the bottom, so you couldn't actually equal out a 0. This is the trickiest part of the day. Most of the homework here might be like, holy Hannah, what is happening here? Most of the homework is this simple stuff. You're plugging in some numbers. You got the little difference quotient that gets a little crazy, and then the domains. You got to be careful on your square root and your fractions. All right, last thing, just something to look at, just for fun. So obviously, you're going to see all these different ways to represent functions. You might see it written out in words, like how we wrote out, we're going to square the input and add 4. That's exciting. You might have it as a formula, like this area is a function of your radius. or for ours, f of x was a function of x squared, so on and so forth. You might have a graph. We're going to see more graphs tomorrow. We're going to talk vertical line tests tomorrow. And of course, you could have a table. You can see how the numbers are paired up to one another in a table. So just some different ways you'll see different functions as we go throughout the chapter. That's all I wanted to show you on that.